Okay, class. In this video, we are going to look at some of the ways that we use the standard normal curve. Um, so, uh, to start off, right, a normal curve looks something like this. Um, well, probably could draw a better one than that. Here, there's a normal curve. Yeah, something like that. Okay, anyways, so standard normal curve. The thing about it is it's a distribution of scores from people in a population. The mean of this thing is going to be right here in the middle. It's actually the mean, median, and mode will actually be in the same spot if the curve is normal. Um, but the standard normal curve, we always say that the mean has a value of 0, and then we look at things. We break it up and separate it and talk about it in terms of, here's uh, one standard deviation, here's -1, here's -2, there's 2, right? And so we can talk about this thing in terms of standard deviations. Uh, Now, what we want to look at is thinking about, like, what does this mean about our population, right? What the standard normal curve shows us is if I look at, for example, the area under this curve, right? If I look at all of the area under the entire curve, that represents 100% of the population. So I could ask, what are the chances of me reaching into this population, and I mean, it's almost a ridiculous question to say, what are the chances of me sampling from the population and finding someone? Well, it's a 100% chance. You're going to pull out something, right? Uh, because so this area represents, right, it's the whole thing, the whole distribution, all of the area from beginning to end represents 100%. If I break it up at the mean and I say, okay, well, how much of the population is below the mean? Well, that's 50%, right? It's half of the population, right? I've got 50% over here, and then I've got the other 50% on this side. And I add them together and I can get 1. And so there are ways that I can break this up and look at this, almost any way that I want, right? So let's erase some of this stuff. Okay. And, all right, so got my standard normal curve. Well, what if I want to know something? Okay, so asking, like, where's the split for 50%, or how much of the distribution is below the mean, that's a pretty easy one. What if I wanted something really specific? Like, what if I said, okay, well, so here's a value, and this is technically it's a z-score, and let's say that it's a value of negative 2.31. Okay, well, how much of the distribution is below a z-score of negative 2.31? And now when I call it a z-score, right, a standard deviation of 1, a standard deviation of 2, those are kind of technically like saying z-scores. All a z-score is it's asking how many standard deviations away from the mean is something. So if I say that something has a z-score of minus 2.31, well, then what I'm really saying is that score is 2.31, it's kind of 2 1/3 standard deviations to the left of the mean. Okay, but this wants to, so I'm asking, well, how much of the population has a value or has a score that's less than minus 2.31? So really, I would say, okay, so what's the area here? Okay, well, I know that half of this area, right, the blue stuff, that's 50%. And if I wanted to, I could use the empirical rule where I could say, okay, well, I know 1-to-1, this is 68%. You're thinking about the empirical rule, right, if that's -1. And then if -2 is here, well, then from here to here, well, that's 95%. But those things still don't tell me anything about what that is, right? And that's what I'm interested in. So where do you get that information? You just I guess the long and short of it is you just read it from a table, right? They have tables that kind of list and show what all of these values are, and you can look these tables up online. It's just you just look up a z table and it'll have all of these values, or the tables are in the book. So for example, here's a z-table, and this is showing, so just to kind of explain how this works, look, this says z, look, there's, because I'm looking at a z-score, and this is saying, look, wherever this thing, here's where z is going to be, wherever you find it, and it's going to give me the area to the left of z every time. Okay, that's what this table is saying. Now notice, all of these z-scores here are positive. Okay, got all of these positive values. But what if z is negative, right? All the z-scores over here are positive, but the z-score I'm looking for is negative. It's on this side, but there's no negative z, so what do? Well, I just turn the page and find the negative z values, right? There's just another table that has the negative z's, and if you look, unfortunately, my image kind of cuts this off a little bit. You can see the standard normal curve up here, right? But so here's z. It's to the left of the center. It's to the left of the mean, so I get all of the negative z values. So let me go back. So I want to know, okay, how much of the population is to the left of minus 2.31? So let's go back here. So minus 2.31 is the value I'm interested in, so I'm just going to go down here and find it. So I scan down my table, and so here's minus 2.3, but I need minus 2.31. So this is 2.30, don't want that one. So here, this is 2.31, okay? 0.0104. Okay, so now what that's telling me, 0.0104. Let me go back over here. So what that's telling me is that this area has a value of 0.0104. Or, right, because this is giving you the proportion. Or this is the equivalent of saying, right, move the decimal place twice, 1.04%. Okay, so this red area right here represents 1.04%, or in other words, what I'm saying is that the proportion or the percent of my population, right, if this is the entire population, then the percent of my population that is to the left of minus 2.31 or has a score that's lower than negative 2.31 is 1.04%, or if it wants it in terms of proportions or probabilities, 0.0104. Those are the same thing, right? So that's kind of how that works. Another way that they could ask this, hold up, can I just clear all? Oh, there we go, that's nice. Okay. Another way that they could ask is they could say, okay, so here's the distribution again, and there's the mean. They could say, hey, well, what percent of the population is between a z-score of 1.15 and a z-score of 2.73, right? What percent is that thing? I want to know how many scores are between 1.5 and 2.73. So to do this, well, let's first start by finding, well, how much of the scores are to the left of 1.15? Okay, so I come over here and I want 1.15. So here's 1.1. So here's 1.10, 1, 2, 3, 4, 5. That's the one I want. So that's 0.8749. Okay, let me take this over here. So this is 0.8749. Is that right? Yes. Okay, so then the other one I'm interested in, we'll do this one in blue, is 2.73. So now I come down here. Oh, okay, I didn't copy enough of this table to get 2.73. So let's pretend that I asked for 2.53, because I didn't copy enough of the table onto my thing. Oh, so look, here's 2.5. Isn't that awesome? 2.7 would have just been a couple more down, but I didn't cut enough of the table. So here's 2.5, 0, 1, 2, and 3. So 2.53, 0.9943, 0.9943. So the blue area, so from here, all of the blue stuff is 0.9943. Okay, so then how do I find the red? Well, if you look, right, here's the blue, here's yellow. If I subtract the yellow from the blue, well, guess what it leaves me? The red. So I'm going to get my calculator out and go 0.9943 minus 0.8749. And final answer, 0.9943 minus 0.8749 is a total of 0.1194. Okay, so that means that between the z-scores of 1.15 and 2.53, I have a proportion of my population that is 0.1194, or this is the same thing as saying 11.94, this is an or, percent of the population is in between those two values. Okay. So that's how that works. There's one other way we can look at this. One last thing that like a problem type that you might see is something that, so here's a normal distribution. What if they ask, well, what z-score let's see here. Let's see. So they could ask something like this, where they say, what if they give me a percentage? What if they say, okay, what z-score has an area to the left of it? So I want to know. So I want to know the z-score. What z-score has an area to the left of let's 0.72%. Okay. So let's think. Let's first stop and think about, okay, where could this be, right? We know that right here, the mean, this area is going to be 50, right? And so I know I'm going to be on this side of the mean. I'm going to have a positive z-score. So it's going to be somewhere over here, right? So I need to find out, okay, what thing has an area that equals 0.72%? Or excuse me, not percent, that's a proportion. Whoa. The percentage would be 72%, right? But the proportion is 0.72. So again, we know we're in the positive z-score values. So I'm going to go over here to my table, and so I'm looking for 0.74. Okay, so now I don't want to look down the z-scores. I want to look in here in the meat of this and find 0.74, right? I want to know where this area is 0.74 if I'm looking for that proportion. So for example, if we look at, just kind of scanning along here, if we look at this row, here's 0.72, 0.73, 0.74. Okay, so I've got 0.739 and I've got 0.7422. So for example, okay, so the 0.739, that is this correlates to a z-score of 0.64. Okay. And the 0.7422, that correlates to a z-score of 0.65. So we're somewhere in between. And really, this is 0.739. So that basically rounds to, like, that's really close. So we're probably closer to 0.64 as a z-score. But we could maybe estimate that we could do 0.641 or 0.642, right, somewhere in that space. But again, we're just making an estimation for that last bit. Okay, so now I hop back and I say, okay, so the z-score that has an area to the left. I mean, I always do that. Okay, so I said 72 on this page, and then my brain turned it into 74. So let's pretend that I said 74 the whole time, because that's what we just spent all of our time looking at. 74, 74. Oh, look, that's what we've been researching the whole time, is 74. So the thing that has a z-score that has a proportion of 0.74 or 74% of the data is to the left of it is, let's see, what did we decide? 0.642. 0.642-ish, okay? And so that would be, right, if this is a z-score of 0, this would be 0.642, and then a standard deviation of 1 would be right here, right? So we're almost one standard deviation away from the mean to figure that one out. But that's what problems, like this is what using the standard normal curve is like, okay? We're hopping around, we're reading this table, and right in here, all of this stuff, these are the proportions or the percentages, and then these are the z-scores that go along with it, okay? Oh, that deleted my picture with it too. Undo that. Let's just erase then, shall we? Okay, so that's that. If you have any questions about this, let me know. Thanks, everybody. Bye.